Speaking of Gomoku, or in other name 5 in a row, I believe most people are familiar with this game, as Gomoku is an invaluable companion in boring lectures in the school days. You can play with another people as long as you have a piece of paper and a pen to draw the square. Just in case you don't know the rules of Gomoku, this is a game where two players are alternatively putting their own signs on the paper as far as one of them manages to create a line of 5 in the vertical, horizontal, or diagonal direction, and due to becomes the winner. Just like AlphaGo created by Google DeepMind in playing Go, there are many excellent Gomoku AI. So the topic in my project is to design a Gomoku AI which can be competitive enough to beat other agents. Due to the fact of the simpler rules in Gomoku than other board games like Go, there's actually no need to consider too many future steps when designing the algorithm. Therefore, the majority of the state-of-the-art AI are based on adversarial search algorithm, especially minimax algorithm, and alpha-beta pruning. So this is also our choice in this project. Minimax algorithm simulates the real reaction of the players in a game to a large degree. It assumes that both players will try to maximize their lowest gains to guarantee a rational choice every step. After the agent puts a sign on the board, the opponent takes another action. For each sequence of alternating action, the game might end and the utility is associated. Both players are attempting to maximizing their own outcomes, but in fact, maximizing one's own value means minimizing the other outcome in this pure competition. Therefore, we can think about one outcome instead of two outcomes, where our agent is maximizing the single value and the opponent is trying to minimizing it. The efficiency of minimax is like an exhaustive depth search with exponential time complexity. The exact optimal solution is somehow impossible to find. There is actually no need to look at an entire search tree to find a solution, so it is crucial to adopt some techniques such as alpha-beta pruning to accelerate the process. Alpha-beta pruning manages to decrease the node number, stopping evaluating a move which is assumed to be worse than a move we have explored before. Here I want to show an example to demonstrate alpha-beta pruning. We are currently computing the value of node n, the blue node in the right of the slide. When we loop over n successors, the minimum value of n successors will keep dropping. It will never go up. If A is the currently best value that the root node max can get at present, and if n is considered to have a worse outcome than A, for example, we know n cannot be larger than 2, and the max root solution cannot be smaller than 3, then we can stop considering n's other children. That's where the pruning is done. To limit the search depth, using a heuristic function to evaluate which moves are more relevant to our agent at the current state is necessary. You may have some similar ideas such as, if I can create a line of 4 with no opponents on the both end, then I can definitely win in the next turn. So we can assign different values to different patterns on the board. For an line 4, we can assign a very high value to it. Since we are using the minimax algorithm and evaluate only one output value, the final value will be assigned as the value of our agent minus gamma times the value of opponent, where gamma should be larger than 1 to emphasize the adverse effect when the opponent gets a bigger chance to win. There are several challenges during the implementation. The most important challenge is to find the balance when designing the algorithm. The balance includes the trade-off between defense and attack. In each step, you need to decide whether to attack more aggressively or to move more defensively and wait for the opponent to make a mistake. This mainly depends on the value assigned to each pattern we have talked before. Another is to balance the running efficiency and the quality of the result. If we explore more nodes, we can choose the better candidate with a higher possibility. However, it needs much more computation and the conversion speed is slower, which may exceed the time limit of each turn. Let me introduce an excellent website to generate your own Gomoku AI. This is the GomoCup website page. You can enroll in the competition when the cup is open, or you can play with other AI offline by downloading the Gomoku Manager and other existing AIs. We use the template provided on the website to generate our own agent. After implementing the algorithm, we can use the PyInstaller to generate an executable file. You can use the command line as the video is showing. You can give your agent another name. For example, here I just name it cute. Remember that all the names should begin with pbrain, otherwise the agent is not valid. To be honest, I saw for this bug for a very long time. Then press the enter, wait for a while. This executable file in the dist folder is our agent. Then we played our agents versus other agents using the platform manager piecework. By changing the setting, you can choose the two players. Computer or human are both okay. Here I use the agent cute, which I just built before, and the agent mushroom. We can see cute beats mushroom very easily. That proves our agent is quite competitive. Also, you can start a tournament if you like. The result can be saved in the text file or the table. Sometimes we could unfortunately lose the game. Then we can see the replay to analyze our failure. Learn from the loss, then improve our algorithm. This is the result of the competition. I chose 5 different agents. As we can see, in summary, our agent can win most of the games when facing the other agents. Admittedly, there is still some gap between our agent and the most powerful agent. But this is enough to say Minimax algorithm is a strong and smart technique. At least, the agent is much better than me. I cannot beat the agent I built. So that's all about this video. I hope you enjoy this video. If you like this video, please give me a like. Thank you for your watching. Bye.
내가 여기 두면 3자. 그러면은 맞고 공격하는 게 아니야. 공격하고 막 여기. 또 이겼죠? 아무것도 못하죠? 뭐해?
넌 뭐해?